That's usually it.
All right, so homework assignment for today was to fill an array up with some numbers, right? Did we already do that part? Yeah, here, we got our array of numbers. Display those numbers initially, so we wrote a little display method that prints them out one line at a time. If you want to make this a little bit to separate them, you can do a system.out.println. Let me make sure I count this precisely. There we go. So put little dividers in there before and after so you see where one ends. So we'll go ahead and display all those numbers. Then we're going to pass it to our sort method, which currently does nothing. That you were supposed to make this work. And then we're going to display them again, and now that should be proof that they're sorted. So this is what ours looks like right now. Not sorted. Okay? So we need to look at an approach for sorting values. So we're going to initially kind of brute force this. Then we're going to look at some better approaches. So how can we go about it? If I gave you a pile of numbers, so let's think about these like on flashcards or something like that, okay? And we shuffled them. And you're going to go and sort these. How would you go about sorting these in real life? Go ahead.
Put them in different piles according to their value.
Okay.
Temporarily. And
So take me through that a little bit more. So, you know, what are the different piles and what are the values?
maybe you would sort them into like a highest to lowest value. You would put numbers that you know are higher into different separate spaces, and then continually do that, and then you would eventually sort them out by placing them in different piles to the highest, from the highest to lowest, or lowest to highest.
Okay, how many piles would you have?
As many cards as you have.
Okay, so you have one pile per card?
Yeah, because otherwise you aren't separating each one of them individually.
Okay, and what card would you put in your very first pile?
The lowest card out of all of them.
Smallest value.
Yeah.
Okay, so we're going to go through here. You're going to find the very smallest value, and you're going to put that in one pile. Then you're going to go through and find the next smallest value. Put that in another pile. So in our case here, we have the smallest value represented multiple times.
Right.
Correct? So we're going to have a 1 in the first pile, a 1 in the second pile, a 1 in the third pile, a 1 in the fourth pile, so on and so forth. Right? Okay. How can we represent those piles in our program? Go ahead.
Spaces of like a temporary array.
Okay, we could just another array. An array that's the exact same size as this array, correct? So we're going to have two arrays. The first one's our original. The second one we're going to start filling up one number at a time, one pile at a time, to get our values. Now, as we go through this, how do we find the smallest number in that array?
You can check to see if it's, well, you could just use a statement and check to see if it's equal to 0, and then go 0 plus n. So
What if we have a negative number?
Oh, true. So you set it just to n. And
Well, can we loop through our array and find the current smallest, the minimum value in there? So might that be helpful initially? Let's find our smallest value. We know the very smallest value in our array will be at bucket 0 of the solution, pile 1, right? Okay. So let's start off by doing that. We're going to go through and we're just going to write some code that's going to loop through every single bucket of this array, looking for the smallest value. Fair enough? So we loop through an array with our typical for loop. In I equals 0, I is less than ar.length, I plus plus. Each time through we want to ask a question. Is the value I'm currently looking at smaller than my current winner? Well, I need to be able to store my current winner someplace, right? Okay, so we're going to have int winner And we're going to set this guy equal to AR at bucket 0. That's going to be our current winner, right? Then we'll ask the question, if AR at bucket I is less than AR at bucket 0, then winner is equal to AR at bucket I. After this loop is done, winner holds the smallest value. We might have more than one of those smallest values, but winner will hold the smallest value in our array. Correct? Okay. So we know if we built a brand new array, we know the appropriate thing to put at bucket 0 of that brand new array is going to be winner. Well, what do we put at bucket 1? Well, we happen to know in this case it'll be winner again by our example, but we need to logically figure that out. So what do we put in bucket 1? Let's go and draw our pictures. So we'll use, I'm just going to steal this array. Ah, I'm an artiste. All right, well, we got everything. So I don't need that, but I'll delete what I don't need. Think you're better than me?
Try to insert and go paste that way.
Sometimes Keynote doesn't cooperate with me. It's an Apple product.
It has its mornings.
What class is this? Here we go. There we go. You look just like the TV show. Did you turn it off and back on again?
Yeah, IT crowd.
It's a good show.
Yeah.
Did you see? You seen it?
Yeah.
I thought you couldn't see.
Yeah, that's a good point. I don't know.
Seems like this
our
close
boss
this
made
year.
us watch it I work in the IT department.
Yep.
So,
Yeah, it's a good show.
yeah,
I like the I like the nerdy black guy. He's my favorite character in it.
yeah, Moss.
Yeah. Yeah, I haven't seen it in like 2 or 3 years. They're not still making it.
No.
No,
But yeah, it's
there's like an American version, but it's really stupid.
oh, they always are.
Yeah.
American spin-offs of British shows are always stupid. Maybe minus The Office. That might be the one exception. But generally speaking, British shows have their own unique humor, and you have to have a British accent for it to be funny.
Yeah.
It's kind of a requirement.
Otherwise, it's just creepy.
Right.
Watch the Mighty Boosh.
Yeah. Speaking of British accents, there's a show. What is it? Yesterday, Today with John Oliver or something like that. It's on HBO. There was a commercial on YouTube yesterday that he was like announcing his show or something. So it was one of them that didn't have any profanity in it, but his guest host was Cookie Monster.
Oh.
Yeah, and so Cookie Monster was giving John Oliver ideas for stories for his show, like why haven't scientists figured out how to make crumbs back into cookies? And why don't they make the entire cookie out of the chocolate chips? That type of stuff, or as oatmeal cookies, just a breakfast food or only a sometimes food. I love Cookie Monster.
These cookies.
Aye. Okay, so we're going to have to build a brand new array here, right? And this brand new array is going to be the same size as our original array, except initially we're not going to have anything in here. This guy just happened to land at memory address 200. We lucked out on this one.
Wait, it wasn't part of. Didn't you want to store traits to the same memory address?
Yeah, but this is a temporary array
Oh, okay.
that I'm going to use for copying this stuff.
Okay.
So this is why we're drawing the pictures.
Yeah.
You know, it helps us understand what's actually going on here. Let me just scooch this guy over a little bit, and then we'll... So we're going to call this guy temp, and temp just happened to get assigned memory address 200, so it points here. All right, makes sense? So we need to go ahead and create the second array that we're going to use. So we'll write the code for that here real quick. Well, first of all, this array has the exact same number of buckets as this array, right? How many buckets are in this array? AR dot length number of buckets, right? So up top here, we're going to go ahead and we're going to create an int array named temp. This guy is going to be a new integer array of size AR dot length. So this one line right here will build for us this empty structure right here. Okay, so here's our array, but has nothing filled in yet. All right, now we just happen to write the code that goes through and finds the smallest value in this guy. So we have a variable in here called winner. And after our loop through, winner became a 1. Correct? So we went through every bucket of this guy. We started winner off at this one. And then we said, is this guy less than winner? No. Is this guy less than winner? No. Is this guy less than winner? So on and so forth. We got all the way to the end. And it just so happened that winner was in our very first bucket. Okay? Now, I know from a human perspective that I'm going to put that winner here. Correct? So I know I can copy winner over to bucket 0 here. So we can just do that real quick. So we'll say temp at bucket 0 is equal to winner. So that's what we just did there. Okay? Now, what's going to go at bucket 1? As a human being, we can look at this and we know it's another 1. But algorithmically, how do we figure out what's going to go at bucket 1? Go ahead.
Something that holds an equal or greater value to winner.
Something that holds an equal or greater value to winner.
Something in the previous array that holds a greater equal value.
Okay, but doesn't 5 hold a equal or greater value
Yes.
than winner? So we're going to put that at bucket 1?
No.
That's going to be that'll be a bad move, right? So what can we do? You all did this, right? Well, ideally, wouldn't it be nice if we can kind of mark that guy off as being already taken? That'd be good, right? Okay. Now, why can't we just put an X in here?
Integrate.
It's an integer array. X doesn't fly. How can we mark this guy as already taken? Go ahead.
When you have winner move to the next bucket to add the next value,
Well, what if winner's here?
well then we have to move it to the first bucket because we
So let's say these were both 2s. So our winner actually lived here. Oh. Hold on, maybe I kind of see where you're going here. So if winner was this guy, so let's just make both these 2s for this quick little example. You want to take this guy who was our winner, and you want to put him here, swapping him with whatever's at bucket 0.
Yeah.
Okay? Now you know that when you find your next winner, you're going to start at bucket 1.
Right.
Okay? I think that's reasonable enough. One problem we have right now is we don't know where winner was located. Right? So we're going to need to keep track of where winner was located. So we're going to need another variable. We're going to need a winner pos. And does this array equal the array had in our code here? Okay, good. So it doesn't really matter what example I use here, right? They're unrelated. Okay. So our winner is going to be 1. Winner pos is 4. Correct? And the first time we go and find our winner, we were looking at bucket 0. The next time we want to start from bucket 1. The next time we want to start from bucket 2. So on and so forth. So we're going to need to have some variable that's going to keep track of next start, our next starting point. So we're going to have next start would have started off at 0. So that's bucket 0 here. We spun through, found our first winner. Winner was right here at position 4. So we got winner is 1, winner pos was 4. We got all the way to the end, never found another answer, right? Okay, so now what can we do? We can take whatever's at winner pos and swap it with whatever's at next start. So we'll put the 1 here and we'll put the 2 here. Make sense? Then increment next start. Does that make sense? Okay, so now the next time through we go to find a new winner, we're going to start at next start, which is bucket 1. Do that exact same thing again. Next start becomes 2. So the next time we find a winner, we'll start at bucket 2. Does that make sense? All right, so now we need to incorporate our next start, our winner pos, into this guy. So let's start off with winner pos. So int winner pos is equal to 0 initially. We're going to be modifying this as we go, taking it one step at a time. If AR at bucket I is less than AR at bucket 0, we'll say winner is equal to AR at bucket I, and winner pos is equal to what? Look at the code. Don't look at me, look at the code. What's winner pos going to be equal to? If AR at bucket I is less than AR at bucket 0, our winner becomes AR at bucket I. What's the position of that winner? AR at I? Isn't that the value of our winner? What's the position of the winner? Just I. Right? The value was at AR at bucket I. The position was just I. That's where we found that winner, our current winner. Make sense? All right, so after this loop is done, winner holds the smallest value. Winner pos holds the index of the smallest value. Make sense? All right, now what did we decide we have to do? We decided we have to do a swap. So we're going to take whatever the winner is, which is at winner pos, and we're going to swap it with next start. Okay? Now we haven't written a next start yet. We know next start's going to be a 0. Then next start's going to be a 1. Then next start's going to be a 2. Then next start's going to be a 3. How could we control next start? What type of structure takes us through all the numbers between a starting point and an ending point? A loop. For a loop. So we can wrap this entire thing next start will start at 0. We're going to keep going as long as next start is less than ar.length. And then each time through, next start becomes 1 larger than it used to be. By the way, for those of you who forgot, on a Mac it's Command-I. On a PC it's Control-I. We'll do that magical indentation thing. 'Cause that's really helpful, especially when you're taking the approach that I'm really pushing in this class right now, drawing pictures, writing code, where sometimes we're writing a small part of the solution and then we have to put that inside of a larger piece of the solution. So we actually put a brand new for loop around all the code we just wrote, and we don't want to just leave it like this. This is hard to read, right? It's hard to know how it's organized. So highlight everything that needs to be fixed, and on a Mac, Command-I will just fix the indentation. One of the perks of an IDE, something like Eclipse. That would have been something this small wouldn't have been a nightmare in a text editor and command line or something, but would have been inconvenient. But if you had 4,000 lines of code that you were wrapping, now we're starting to borderline nightmare type stuff. In fact, I actually remember, so computer science related story, back before we had these, I actually did all my programming out at the terminal in my early days of programming. So I would write all my code using a command line text editor called VI. So for this guy, you would have had to go line by line by line by line, and you actually give it commands to do stuff. It's all the idea. It's built for touch typing, so you never actually have to. I mean, this was before mice existed. So I'm older than you. But I'm younger than I should be for having taught 16 years. But I've already had my day in the sun at this point, I'm just getting dumber. Things are becoming more fuzzy. All right, but in any case, it was a nightmare here. So I remember writing programs. Like let's just say I had to do that indentation thing that I just had. I would write a secondary program that would take a couple command line arguments, the name of the file, the starting line and the ending line that I wanted to indent. And it would read in that file, programmatically indent those lines, and then write the result back out to the file. So I would build my own feature that we just had here, because that was the convenient way of doing it. Those were the good old days when you actually used your computer rather than having these power tools given to you. Man, can you imagine life before Google?
Oh,
Actually,
I would have never found all those pictures of a goat.
How many of you guys have used a telephone book? We had a museum.
I had to find gaggles.
You're right at that borderline.
Yeah, I think we're like some of the last ones.
Yeah. It's like, what's a telephone? Even up to like 3 or 4 years ago, I think at the beginning of every year, we'd still get a telephone book.
Still get 'em.
Throw it in. It was like in a plastic bag, but they keep getting smaller. So the phone books are like I don't know, like the size of like a I don't know, an iPad Mini or something, and just really thick. Now, who uses that? I used it for like packing material. You just wad up the paper.
Until the one day when you need the phone book when the internet goes out.
There's always a source of the internet. Wi-Fi's down. Hopefully the cell phone network's up. Cell phone network's down. Drive to McDonald's.
Their internet's down.
Yeah. If McDonald's internet's down, then a sign of the apocalypse.
Yeah.
Yeah.
No, try Starbucks.
That's the algorithm for when has it begun.
This 2 years ago. It was funny because there was like a Verizon outage, and it was like sporadic in places.
Okay.
There's times when that happens.
Yeah, you have to have your pecking order of reliable places for internet. Okay, home Wi-Fi. Concordia doesn't count.
Yeah.
No.
Hey, that's not part of the algorithm. You got your home Wi-Fi, then you got your cell phone network, then you got McDonald's. Maybe you can throw Starbucks in there. Okay, I think McDonald's and Starbucks use different
Throw
providers.
Target in there. 'Cause they know-
Target has Wi-Fi?
What?
I didn't know that.
It might
You
not be
use
very
credit cards
well.
info stolen.
Yeah.
Yeah, it's now on the door when you walk into Target in Grafton.
Oh, that's interesting. All right. So in any case, little tangent related to indenting your code, but understand this is one of those conveniences that an IDE gives us. All right. Shut up! It's like a power trip thing for me. I get the whole room. All right. So we've done our indenting. Next start's going to go from 0 to 1 to 2 to 3 to 4. We're going to start winner off not at 0, but at next start. Right? We'll start winner pause also at next start. Remember, this code right here, everything I have highlighted there, the job of that code is to find the smallest value in our array starting at position next start. So the first time we'll start from bucket 0, which is the whole array. Next time we'll start at bucket 1, which is almost the whole array, so on and so forth. Okay? So our initial possible winner will always be the first guy that we're looking for. Well, the first guy in the collection of numbers that we're looking through, I guess is the better way of putting it. So current winner is AR at bucket next start. Winner pause is next start. All right. So then we're going to go through our array. We're not starting at bucket 0. Instead, we're starting at bucket next start. First time through, that'll be 0. Second time through, that'll be 1. So on and so forth. We're going to keep going all the way up to, but not including the end of the array. Well, the length of the array. So this goes up to the last legal bucket in our array, incrementing I each time. All right. If AR at bucket I is less than AR at bucket 0, we don't want AR at bucket 0. Actually, why did we have AR at bucket 0 there in the first place? This wasn't even correct code. Why didn't somebody fix this? What should be here? This should be a quiz. Remember, this code right here tries to find the current winner starting at position next pause. This if statement tries to ask, do I have a new winner? I shouldn't be comparing AR at bucket I to AR at bucket 0. What should I be comparing AR at bucket I to? I want to find out if I have a new winner. We get a new winner when the current guy beats the old winner. Who's the old winner?
AR next.
Who's the old winner? So if the current value we're looking at is smaller than our current winner, then we'll overwrite our current winner with our new dude and overwrite our current winner pause with the position of our new dude. Make sense? I think we had the AR at bucket 0 there when we were doing this at the very initial level. Okay? But should be winner. This says, does the current guy we're looking at, is he a new winner? Which means he has to beat the current winner. After this loop is done, winner holds the smallest value. Winner pause holds the index of the smallest value. Before we put our winner in bucket temp, or in our array temp, won't be at bucket 0, but before we put it in there, we need to do our swap, right? We got to do this guy, where we take our winner. Let me go back to where okay. So we got to take our winner, which was this guy, and we want to swap him with position next start. And in order to do that swap, we're going to need another variable. Because what happens if I just overwrite this guy with my winner?
You just lost it.
I lost the 2. Okay, the guy I was meaning to swap is now gone. Okay, so I'm going to need another variable. So let's call this guy swap. And what we'll do is we'll go ahead and we'll load swap with, let's just say winner. Then we'll overwrite winner pause with whatever's at next start. Then we'll override next start with whatever's in swap. That make sense? So let's write the code associated with each of those steps. First thing, we're going to fill swap up with whatever's at position winner, winner pause. So we're going to create a new variable. And this guy is going to be equal to AR at bucket winner pause. Then, let's just close the terminal. Then I'm going to overwrite bucket next start with whatever's at bucket. Actually, I'm sorry. I'm going to overwrite bucket winner pause, which was with whatever's at bucket next start. So AR at winner pause is equal to AR at next start. That'll put the 2 here. So now AR at winner pause is equal to AR at next start. Then AR at next start equals whatever's in swap. That's where we get the 1. Equals swap. So these 3 lines swap the position of the current winner with the position of next start, getting the guy at the beginning of our current array, current portion of the array we're looking at. All right, now we can then move our winner into, well, copy our winning value into our temp array. And that's going to go at bucket 0 the first time through, or, remember, next start off at 0, or at position next start. So we're going to say temp at bucket next start is equal to winner. So temp at bucket next start is equal to our winner. Next thing that'll happen is next start's going to go up by 1, and our loop takes care of that for us. Make sense? All right, so let's kind of follow this. So the first time through, next starts out at 0. Let's put these guys back. Winner starts at the thing at 0, at next start. Winner pause starts off as next start. All right, so the very first time we actually compare it to itself is a 2 is whatever's at bucket next start less than a 2? It's not, so move on. Is a 2 less than a 2? No. Is a 3 less than a 2? No. Is a 5 less than a 2? No. Is a 1 less than a 2? Yes. We just got inside this if statement. Is a 1 less than a 2? It is, so we'll replace our winner with a 1. Our winner pause with the current bucket we're looking at, which is going to be a 4. And we got the 4 from I. All right. So if we want to throw I in here as even another variable that it's existing, here's I. I is currently 4. So winner is whatever's that bucket for. Winner pause is 4. Spin up again. I is now 5. Is whatever's that bucket 5 is a 9 less than a 1? No. I becomes 6. Is a 4 less than a 1? No. I becomes 7. I becomes 8. I becomes 9. Okay? So now that inner loop, this guy has finished going through all of the buckets in the current portion of the array we're looking at. So winner should hold the smallest value. Winner pause should hold the index of that smallest value. Go ahead.
Where do we get swap from? So, like, in our code,
Right here.
We threw swap down there. Oh, yeah.
So we created a variable called swap, stored in that variable whatever was at winner pause, which is the same thing that's in winner. Then we wrote our bucket winner pause with bucket next start. Then we overwrote next start with whatever was in swap. We had to preserve one of those values in order to do the swap. All right, so we finished the inner loop. So I is currently 10. Is 10 less than the length? No. So we finished that inner loop. Now we know that winner holds our current smallest value. Winner pause holds the position of that smallest value. So we're going to go ahead and load into swap whatever's that winner pause. Winner pause is 4. The value there is a 1. So we'll load into swap that 1. Then we'll overwrite our array at bucket winner pause here with whatever's that bucket next start, which is 0. So we'll overwrite that guy with the 2. Then we'll overwrite next start with whatever's in swap. All right, then next start gets incremented. Next time through, winner starts off as 2. Winner pause starts off as 1 because that's the beginning of what we're searching. It's next start. So here's the 2, which is that position next start. So we're looking for our next smallest value. That is the smallest value starting from here all the way to the end of our array. Because we know that our very smallest value is already here. Now question, do we even need this temp array? We didn't need those stacks. We didn't even copy anything into this. Because we're doing it within the original array, aren't we? Isn't this the smallest value in the entire array? It's the guy that's going to arrive at bucket 0 in the end, right? So I can get rid of temp. Which means I don't need this guy. Which means I don't need that guy. The swapping was enough. Okay? So we just optimized our picture. We saw that we didn't need something. Okay, so now next time through. Next start is 1. Winner starts off at the value at next start. Winner pause is equal to next start. I starts off at next start. Let's make sure our code says that. Here's our inner loop. I starts off at next start. the beginning of the portion of the array that we want to find the smallest value from there on. Okay? So, we start with that. Is a 2 less than a 2? Nope. I becomes 2. Is a 3 less than a 2? Nope. Is a 5 less than a 2? Nope. Is a 2 less than a 2? Nope. Is a 9 less than a 2? Nope. Is a 4 less than a 2? Nope. Is a 1 less than a 2? Yes. So we're inside of this if statement. Right here. We're right here, right? So winner will be a 1. Winner pause will be the position of that winner, which is a 7. I becomes 8. Is a 3 less than a 1? No. Is a 5 less than a 1? No. We're done with that loop. I is 10. Fall out of the loop. At that point in time, winner holds the smallest value. Winner pause holds the index of the smallest value. Fair enough? All right. We do our swap. So we're going to swap whatever's that, well, we're going to store into swap whatever's that bucket 7. So we'll store 1. Then we'll overwrite bucket 7 with whatever's that bucket next start, which is a 2. Then we'll overwrite bucket next start with whatever's in swap. Next start becomes a 2. Winner becomes whatever's at bucket 2, which is a 3. Winner pause becomes next start, which is a 2. I starts off at next start, which is a 2. We do the entire thing again. Make sense? Is that sorted? So we proved our code worked by drawing our picture. Wouldn't that have been difficult to conceptualize entirely in our head? How many of you drew pictures for this homework assignment? How many of you who didn't draw pictures got it working? Without Google.
You show something else you showed us.
Very interesting. Very interested in the number of solutions that mimic a bubble sort, which I would have been very surprised if you would have just come up with off the top of your head. We actually wrote something here that's, I don't know, in the same vein, if you will, as bubble sort, which we're going to talk about here next. But not quite as efficient. All right, so that would be one solution to the homework assignment. Things that were not allowed is using, I think, array.
I didn't know that.
We didn't know what?
I didn't know we could use it. You showed us the Oracle database. It's in there.
Arrays.sort, isn't that what it is?
Arrays.sort.
Yeah, so really you could have just commented out all this code.
Just on array.sort.
And just said arrays.sort. KK, thanks. And, and there we go. Not allowed to use that. Still not allowed to use that. Okay. So officially not allowed to use. You use that?
Yeah.
I never told you. How many
I've been
times?
sitting on Oracle every night studying stuff on there.
Okay,
for
so you
25.
stumbled upon that.
Yes.
You didn't. That wasn't a Google thing.
No.
I did the
When we
same
started
thing, but I
talking
was
about
doing-
arrays.
Steve Johns.
No, he's telling the truth.
I have made it quite clear that you're not allowed to use stuff that I haven't introduced in class, right?
But I've used stuff from 320.
Not that.
25.
I haven't introduced that in that class
No.
either.
Well, you kind of said that you were okay with it if you didn't specifically say you couldn't use it. I don't recall you saying specifically that we couldn't use
There's literally a reason I have this.
Did you use it as well?
No,
I had no idea it existed.
And officially, you still have no idea that it exists. I just erased your memory of this.
Oh.
Yeah.
Wait, what were we talking
I just untaught that to you. Now understand, I'm not just being a jerk by saying you can't use some of these things. There's a means to an end. And not my first rodeo of teaching this stuff. First of all, everybody in here was impressed that we could have accomplished everything we just wrote with that one line, right? Like, that would have made homework easier. Okay?
Isn't that one line almost exactly the same as that, though?
Well, actually, inside, though, that one line is probably using what's called a quick sort. But regardless, so there's a bunch of different sorting algorithms. We're going to look at a couple. But it was probably using a quick sort, which is fine. So when you're out in industry and you need to sort an array, of course use that. All right? But right now we're students. We're trying to understand the means to an end. Okay? We learned a lot in going through this process of drawing this picture and letting our code kind of organically grow from that picture. Because not everything you're ever going to need to do is going to be built into the language. We can kind of extrapolate that things like sorting are probably kind of common things. Even if you didn't look for it, you probably could have guessed. If I had asked you a true-false question, is sorting built into the language, true or false? Probably would have guessed true, right? All right? But there is a means to an end. Next semester, when we do linked lists, in the 300 class, we're going to write, it's terrible. You're going to hate me. Okay? And I'm going to show you it's just built into the language. And it's so much easier. But guess what? You already built one and you know how it works. Like you said, you built a hovercraft, right?
Yeah.
That was hard work, wasn't it? Well, dude, I couldn't build a hovercraft. Okay, now you know how to build a hovercraft. If you had an unlimited amount of money, wouldn't you just go out and buy a hovercraft? Maybe not you. You're kind of wired a little funny. But generally speaking, if the money was there, instead of spending a month building a hovercraft, we're probably going to go out and just buy a hovercraft. It's probably going to be built better. At least if I was building it. My hovercraft would probably weigh 6 times what it should weigh because I'd over-engineer it.
Dual hull.
Military. Did you see that Arnold Schwarzenegger did that? There's a funny YouTube video that we can't show in class because there might be some questionable language in it. But Schwarzenegger, when he was in, I think he's Austrian, when he was in the Austrian military, we all know who Arnold Schwarzenegger is, right?
I hope so.
Okay. Now, do we know him as California governor or
No.
action? Yeah, he was the Terminator.
Yeah.
Guy used to be in all the good movies. Conan the Barbarian. And, all right. So, in any case, he used to be in the Austrian military and drove a tank when he was in the military. Well, now he's like rich, right? He's since gone back and he worked with the Austrian military as well as the United States government. He was a good governor, so he kind of had some ties to make it so that he could buy the tank he used to drive. So now he has this tank, and this video that I already said I can't show in class.
Well, you can
But-
show without the audio and sometimes.
Yeah. But he's basically inviting you to come out to California and crush stuff with his tank. And he just random stuff.
Cars,
Just
trash cans.
come and crush stuff with my tank. All right. So, in any case, I don't know how that's related, but anyways, Schwarzenegger has a tank. Okay, it will be on the final. That will be on the final.
I have seen the video. It's hilarious.
All right, now. All right, shut up. So now let's look at a little bit more efficient version of this sort. Okay, before we do that, any questions about what we just did here? This would have been difficult if we would have just sat down and started writing that code. We wouldn't have been able to conceptualize that. But by drawing the pictures, it became paint by number, didn't it? I'm not saying this was trivial for us. But as human beings, we could solve this problem. we're given a bunch of pieces in front of us, we can kind of start messing with stuff until we kind of find that pattern of what we need to do to make this all work. That's what we're searching for when you're solving these problems. Finding that algorithm, coming across that pattern that as a human being, we can just keep repeating that pattern and get the final result that we want. But you got to draw the pictures in order to do that. So what I'm going to do here, well, let's actually just do it with a new slide. We're going to introduce something called bubble sort. Is this my original, how many of these do I have? Oh, okay, whatever. Good enough. So I'm going to get rid of all these things for right now. We'll be putting some of them back. The way bubble sort works, it actually is roughly similar to what we just did. Roughly. What we're going to do is we're going to create a couple of variables here. So we might have something called cur_start, and cur_start's going to start off at bucket 1. Now I'm going to go ahead and put some arrows in here. This isn't necessarily a pointer, but it's going to help us kind of visualize how this is working. Okay, so this guy isn't actually a pointer. We'll make it a different color. There, orange. All right. Now, again, it's called bubble sort. So the idea is that we have a current start value, and what we try to do is we try to bubble it towards the top of our array, towards bucket 0. So we start here, we bubble the 1 as far forward as we can. Then we start here, we bubble the 3 as far forward as we can. We bubble the 5, we bubble the 2, we bubble the 9. By the time we're done, everything has bubbled to the surface, as far up as it can bubble. Okay, so let's kind of walk through this and we'll see this work. I'm gonna throw some values back in here. So this was a 1, right? And this was a 1. Okay, so we're back to our original here. So we'll start off at this 2. Is 2 less than 2? It's not. So we're done with this guy. Now we'll move to the 3. Is 3 less than 2? No. We're done with this guy. Is 5 less than 3? No. Now we're at this guy. Now we got some bubbling to do, right? Is 1 less than 5? Yes. So swap them. 1 goes there. 5 goes there. We'll follow. Actually, we won't follow with cur_start. We're going to follow with we'll make it a creepy name. The follower.
Just add Goten for
Follower is better.
because
Because that's what he does. He is the follower.
Well, then it could just
Okay,
be-
so we just swapped here. So follower and cur_start both pointed to the same place. They were both 4. But then we did the swap, so the follower now went to 3. And that's important because we don't want to lose track of our current starting point. All right? So, should a 1 come before a 3? So should the value at the follower come before the value at the follower minus 1? It should. So we'll swap again. And we know from our last example that we're probably going to need an extra variable for that swap, right? And then we follow with the follower. All right? So the follower is now a 2. Should a 1 come before a 2? Yes, so we do the swap. And we follow. Should a 1 come before a 2? Yes, so we swap. And then we follow. Should a 1 come before an illegal position? Okay, so we know we have to stop once the follower gets to a 0. Right? That's the end of the line. Then we increment cur start, set follower back equal to cur start, and repeat. Should a 9 come before a 5? Nope. We're done. That 9 has bubbled as close to the top as it can. Increment cur start. Increment the follower. Should a 4 come before a 9? Yes. Swap. And follow. Should a 4 come before a 5? Swap. And follow. Should a 4 come before a 3? No. We're done. Increment cur start. Reset the follower. Should a 1 come before a 9? Yes. Swap. Should a 1 come before a follow? Should a 1 come before a 5? Kind of see where we're going here? Every single value bubbles to the top. Okay? Cur start goes from 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9. What does that sound like to us? A loop. So let's write a method here. So we'll have our loop for int cur start is equal to 1. Keep going as long as cur start is less than ar.length. Cur start plus plus. So this is going to be the guy that takes cur start on an adventure. Right? All right. Now, we need the follower. Isn't it funny how it sounds more creepy when you say it with the voice? All right, so I'm going to go ahead and create the follower as a global variable here. Well, a local variable global to this method. Just to point out something quickly here. Typically, I don't like this type of thing we did down here. We just kind of rolled with it because of how our code organically grew. Every single time through this for loop, we redefine this variable. So we created winner, and then we overwrote winner. Created it again. Actually, under the hood, because of the way compilers worked, it made it work efficiently for us. So it actually didn't become a problem. But typically, if we know we need a winner and we need a winner pause, define them prior to the loop and then just use them in the loop. Make sense? This isn't wrong, what we did. In fact, what we did probably allowed us to organically grow it in a cleaner fashion. So what I would probably do is after the fact, I'd look at the code and then go back and kind of define them in a more appropriate place. But if you left it like this, nobody's getting shot, is what I'm getting at. This is more just a programming etiquette type of thing. Trivia knowledge, I guess. So we have the follower. The follower always starts off at wherever cur start is, right? Remember, every single time through here, when cur start increased, follower got reset. And then follower potentially followed all the way to the beginning of the array. So the follower will always be equal to cur start. Make sense? All right. Now, we need to do the bubbling. Dun, dun, dun. Whoa. All right. So, couple different things. We're going to keep bubbling as long as what is true. And what does it mean to bubble? Bubble means swap, correct? That's what our bubbling procedure means, is to swap. But we're going to keep bubbling as long as whatever the follower currently points to should come before the guy right before the follower.
So if it's less
Yeah, if it's less than. But we also want to take into account that the follower is not at bucket 0. If the follower is at bucket 0, we know we're done. Okay? So while the follower is not equal to 0, and the follower is less than, well, whatever value's at the follower is less than whatever's at the value follower minus 1. Okay? How long are we going to have to swap? We don't know. What kind of loop lends itself to we have to iterate some number of times we don't know? While loop. So we'll say while the follower is not equal to 0 and AR at bucket the follower is less than AR at bucket the follower minus 1. While both of those are true. Now, an important thing to point out here, and this is very important information to know about how programming languages work, because this is an AND, and I've probably pointed this out before, but it's important to say it again. Because that's an AND, if this first Boolean expression is false, it won't even check the second. That make sense? So, if the follower is equal to 0, we won't even check the second, which then prevents us to having a problem of accessing AR at bucket -1. That make sense? So it's an important feature of how loops work, or how programming languages work. So if we're not at the beginning of the array and we should swap, then we will swap. So I'll just do the same thing I did in the previous one. So we'll have int swap is going to be equal to AR at bucket the follower. Then AR at bucket the follower is going to be equal to AR at bucket the follower minus 1. And then AR at the follower minus 1 will be equal to swap. So that's our little 3-step move to swap those guys. Make sure we preserve those values. All right, and draw a picture. You know, I've been doing this a while, so I know this is right. We could have also preserved the follower minus 1, then overwrote the follower minus 1, then overwrote the follower. So could have done it 2 different directions, but just make sure you don't overwrite values before you preserve them. All right, so this will do our swap. Then the follower follows. Make sense? So it follows the value it just swapped. Loop back up, try to do it again. As soon as this guy is done, that means what? Either hit the beginning, and well, any way you cut it, this dude has bubbled as far as it can go. It's either gone all the way to the front, or we've hit a point where it can't swap, because it shouldn't swap. All right, what happens next? We loop back up, cur start becomes 1 bigger than it used to be, reset the follower. Sorted? A little bit more compact. But not necessarily dissimilar to what we did. But what we did, something you'll deal with in the senior seminar class, you'll deal with the big O notation for the efficiency of algorithms. So, without going too deep into that, this guy would have an order of a lower value than this guy. It's the number of comparisons is really what the big O notation, number of comparisons on average something has. So we're actually doing less comparisons with bubble sort than we'd be doing with our made up sort. But did it really matter? Or did they both seem to run instantaneously? Absolutely. No big deal, right? Okay. So now, should I be mean?
Mm-mm. I don't like mean.
Oh, I think I should be.
What are you doing next Tuesday?
Huh?
Oh, I got tickets to a Bucks game.
I'll
I got tickets to a Bucks game.
go to the seats.
I don't know. I haven't gotten the tickets.
Well, let me know and we'll talk.
He's trying to persuade you not to be mean. So.
I actually do want to get out to a Bucks game again this year. I used to have season tickets to the Bucks, but I had floor seats, so I'm a little spoiled. I don't like to sit up in the rafters. Yeah. Actually, I've been in them a bunch of times, and every single time I've been in them, it's when they're trying to get me to renew my season tickets. So I usually play the game, because I haven't had season tickets for the last 2 years. So I play the game where my ticket agent, he comes in, he's like, well, let's talk again. You know, or if I want to come out to a game, like, yeah, I'm thinking about getting those tickets again. I like the used to be called Club Cambria, now it's called something else. The all-inclusive thing up top at one of the end zones. So it's buffet food and open bar, that kind of, and rolly chairs. I don't fit in those normal hockey seats. I like the rolly chairs. It's like this kind of chair. Like, oh. That's how to watch basketball. Yeah, the Bucks don't suck too bad yet this year. Better than the Cavaliers.
Really?
So I would say so far. Have the Cavs won a game? Oh, because LeBron went back to Cleveland and they're not sinking quite yet.
Wow.
Well, I mean, they put together that team before they realized they had the league's best player coming back in. So I guess it's proof that it takes more than one player.
They're 1-3.
Cavaliers. Okay. Again, a reminder, you cannot use that erase thing. I'm going to give you this code as a starting point, and then I'm going to scare the crap out of you.
You know, if you wanted to incorporate a Christian worldview, you could say, like, what would Jesus do? And he wouldn't give us homework, so
Really? Why?
Create or
Doesn't Jesus want you to learn?
I don't know.
create a method called "What Would Jesus Do?"
We can go that route. See, he didn't even stand his ground. He like immediately backed off.
Well, I'm not going to tell Jesus.
How am I supposed to have respect for that?
No.
Just saying.
No, he was just asking me to consider what Jesus would do in terms of assigning homework. He didn't call me Jesus.
I'm just saying I got
You have to have a little bit more of a beard. A little bit.
All right. What class is this?
decent for that Bucks game, actually.
And we haven't had enough homework assignments.
Only 12.
I think we've had
12, I mean, that's
We haven't had a break from those in a minute.
Yeah, isn't that good? You have 2 classes a week. Given the following code, modify bubble sort to sort an array of strings. Note that you will have to write your own method for determining if a string should alphabetically come before another string. you can assume that all strings are lowercase. So you don't have to deal with uppercase or lowercase comparisons. All right? So when you draw your pictures, you're going to ask yourself, hey, I'm a human being. I have 2 words. Which one should come first in the phone book? Okay? And then how did you come up with that? So the hard part of this guy is that method. Write a method that takes in 2 strings and returns the string that should come first, or whether or not one string comes before the other string. You can decide how you want your method to work. Well, you're going to modify bubble sort. But what I'm telling you is that, where's my bubble sort? This part of bubble sort right here is going to need to be modified. The rest of bubble sort should work, except swap will be a string, that kind of stuff. But this one line I have highlighted there, we're not comparing integers. We can't just say, does this int come before this int? We need to call our method to find out if this string should come before this string. That make sense? Draw pictures. Any size array. But so would our bubble sort right now. If I gave it an array of 4 million numbers, it would work without changing it at all. And there's the code for the starting point. You can't use arrays.sort. You also can't use the built-in method in strings that allows strings to be compared to other strings alphabetically. I will be showing that to you later next class.
I love this website. I start looking up topics when we start going over stuff.
Are you doing lunch?
Yeah.
I was just about to ask you that.
Stop.
Just unbookmark the website for now. Put it off my quick